Hello and welcome to the lesson on river processes, and today we're going to be looking at the process of transportation. So our three key takeaways are to describe the different processes of transportation, to explain how and why they change along a river, to link these processes to locations along the river as well. So to begin with, if you have a pen and paper, it's probably worth jotting down this definition. So transportation, this is a process where a river moves its sediment in order, the process where river moves its sediment, that's the ultimate definition. Now in order to do this, the river needs energy, okay? You can't pick anything up if it doesn't have energy, okay? And sediment size, the material that the river carries, also varies along the river. So that's something that we need to consider as well. So if you have a little look at the box right at the very bottom, okay, we might notice that it's called the Bradshaw model, and it basically identifies how certain characteristics change along a river. So to begin with, it shows discharge, which is the volume and speed of water over a certain point, average velocity, which is speed of water, load quantity, which is the amount that the river is carrying, and the load particle size, which is the size of the sediment that the river is carrying. So these factors will basically determine what form of transportation is happening and where it's happening on a river. So our question that we want to start off by thinking about is, what do you think happens to a river, to a river's energy and sediment size as you go downstream? So what happens to river energy and sediment size as you go downstream? So have a little look at these two pictures. So we've got one just over here, which shows our upper course river, so upstream river, and we have one down here showing our downstream or lower course river. Okay, we can also use this Bradshaw model in the middle to draw together our findings. So in theory, what we are looking at, if we look at the image on the left, we can see that discharge, that's the volume and speed of water for a certain point, is much lower. We can see that from the middle Bradshaw model diagram. Okay, that triangular point is much smaller, so therefore we can see that the river discharge is smaller, therefore there is less energy to move sediment. So energy is important in moving sediment, so there's less energy in the upper course, so therefore sediment is going to be much more difficult to move. Okay. What we also notice is that particle size, so I'll call it sediment size, is larger, so more energy is needed to move it. Okay, so that's another point about transportation, quite an important point there. Okay, so in terms of load particle size being larger, and therefore there's less sediment that can fit in the river, so load quantity is going to be smaller. In terms of it being much larger, it's basically the river doesn't have the energy to break it down yet. Okay, so that sediment isn't going to be eroded down and made smaller. It's still going to remain really big. If we hop over to the other diagram on the right, so downstream in our lower course, the river discharge is higher, therefore there is more energy to move sediment. Okay, so this is the opposite now. We can also notice that load particle size is much smaller and our load quantity is bigger. So a bigger channel which has smaller sediment, so there is more small sediment that can fit in that channel. Okay, So sediment size, whoops, is smaller, so less energy is needed to move it, to transport it. So this is ultimately the clear difference between these two parts of a river. Okay, so energy plays a big role. We can see there's more energy lower downstream than there is upstream, and sediment size plays another role. Okay, and we can see that sediment size is larger in the upper course and smaller in the lower course. So what we're going to do is, with this information, we're going to look at what the forms of transportation are, and it comes down to 4 key terms that we need. So in terms of transportation, we are looking at traction, saltation, suspension, and solution. And you can see a diagram that represents them in the middle. Now you've got 4 definitions on the far side. So we've got movement of dissolved material, fine particles that float in the water. Small particles are picked up and dropped off by water, creates this hopping effect. And then we have larger sediment are rolled on the bed of the river. So they basically roll along. They never really leave the bottom of the riverbed. So you can have a little think about which key terms match which definition. And what we'll do, we'll pair those up. So use a diagram to help you. So we'll start from the bottom. Okay, we'll start from the bottom. Let's do a red arrow. So solution, this is the same key term to in the erosional processes. Okay, so solution, just like in chemistry, and we can see from that image there, solution is kind of cloudy. We can't see any particles really. We are looking at the movement of dissolved material. Okay, tends to be invisible. You're not going to see it. Okay, so that's why it's really fine, almost like a white colorless. You're not going to see that. Okay, so solution is dissolved material. Now suspension, moving upwards, we can see it's floating or hovering in the water, just like a car. Suspension holds that car, keeps it suspended in air, in essence. Suspension, this is where we get finer, lighter particles are floating in the water. Okay, so suspension are these finer particles. They're still visible, but they float in the water. They're light enough to be held up in small currents. Okay, so just like being suspended in midair, the fine particles are suspended in the water, and they can sometimes make the water look a little bit cloudy. If we look at saltation, so there we can see smaller particles. You can see some of them are off the bed of the river, but they're nearer to the bed of the river. So they're not large particles, they are small particles. So we'll draw an arrow to that one. So they're picked up by the river, and they kind of make this hopping effect. So they bounce up and down, and they make this hopping effect along the bed of the river. So that is saltation. And our final one, therefore, is traction. So just think about a tractor being used as heavy machinery, but traction is our heavier material that gets rolled along the river. Okay, so it's really heavy material, so heavy that the river can't really pick it up. It's just this rolling effect. Never really leaves the bed of that river, just rolled along. Okay. So for the larger sediment, it needs more energy. Okay. So traction needs more energy. with our ones like suspension solution can happen with low energy, especially solution. Okay, so these things can vary from place to place. So what we'll do is we'll pick out a few different images and work out what form of transportation could be happening there. So I will clear this. So which form of transportation might we find at each image and why? Okay, so I've got that diagram where you can remind yourself those key terms. You've got two images there. Okay. Now in terms of where we're looking at in a river, well, we can see that the image on the left, we are looking, well, we can see it's shallow water because we can see that white water, and we can see that there's some large sediment, but we can also see a stepped effect. So we can assume that we're in the upper course. Okay, therefore it tends to be low energy, but just keep that in the back of your mind for now. Okay, we can just assume what form of transportation might be happening there. If we look at our image on the right, we can see that the river looks wider, it looks deeper, we can't see any white water. It looks relatively flat as well, so we can assume that we're either in the middle to lower course. Okay, so therefore we can assume that there's slightly more energy, but same again, just hold that in the back of your mind. So what are the key things that we can see in these pictures? So first of all, we can see white water, so we know that there's not much energy. We know that the water is going to be very shallow, but we can see some large sediment there. Okay, it looks like the water is clear. Okay, it's difficult to see, but we can assume that the water might be clear. Okay, if we look at the image on the other side, it's difficult to really make out what's happening. We can see it's deep, but we can see that it's got this brown quality to it. Okay, obviously we can't see what's happening through the water or at the bottom, so we might need to make an assumption. So in terms of what we can find, so first of all, we are looking at large material, so large sediment. So we will link this towards traction, but I'll put this in brackets because in theory it needs a lot of energy to move that. We can see there's large sediment, so we know traction would take place, but upper course river energy is much lower, so this is not very likely to take place. So due to low energy, it is unlikely to take place. Okay, and because of that low energy, that sediment takes a long time to be broken up into smaller pieces. Okay, so the only thing that will change that is if we have a storm or flood event. This can break down or erode down material, sediment. So that's what it can do to allow potentially saltation to take place or suspension to take place. So a storm or flood event, this can erode down sediment, making it easier to transport. But this won't happen every day. Okay, or in the storm event, traction can take place. So it won't be constant movement, but that storm or flood event will definitely trigger, and I'll just highlight that. Oops. Just highlight that there. So this storm or flood event will definitely play a big role in actually creating this traction, allowing that sediment to be moved. Okay, now what else can we see? So I will continue to write this in black. So potentially where that water is clear, we can assume that solution could be taking place, which is that dissolved material, dissolved sediment, things that you're not going to see. We can assume it's there, but that's all we can really assume. Okay. So if we hop over to our other image, well, we can see that the water looks cloudy. So cloudy water. Oops. Cloudy water means fine sediment is hovering. Okay, so that means it's got to be suspension. Okay, we can clearly evidence that happening, and that gives it this murky brown color. Now, it might be that there are other forms of transportation taking place, but we can't see that. So we can assume that there'll be solution dissolved material. We can assume that there might be saltation because there's more energy. There might be saltation on the riverbed, but we can't see that taking place. But with more energy, I'd assume that there'll be more than just suspension taking place. So then we'll clear this and we'll have one more look. Okay, so moving away from those key terms, which transportation process would we expect to happen going right back to the start at each process and why, at each of these sites and why? So key things to identify here are, we are looking at, looks like clear water. It also looks like low energy. Okay, so at those particular points in the river, we're looking at clear water, so all we can assume is that solution is taking place. Okay, and there is low energy, which means potentially we could argue where it's shallow there could be traction if we think back to that Bradshaw model. So it should be traction, but we know that's only going to be happening in a storm event. Okay, so in theory, with the large particle size, there's not going to be much erosion, and the low energy, there's not going to be much transportation taking place. If we look towards the lower course, okay, we can see that we've got clear water, so we can assume that solution will be taking place along here. Now, if we're being really picky, we might be able to see just there, where it's not quite the sandy part, we could assume that there could be suspension taking place. Just in this part where it might be a little bit more sheltered, water is becoming suspended as it slows down. Okay, so fine particles could be carried from this little sandbank if we're going to be really particular. Okay. Now we can assume that it's higher energy, so we're going to be expecting, so higher energy, we can expect saltation, okay, as well, but this would be at the bottom of the river, so we might not necessarily see it. Now, in theory, our particle size will be much smaller, so we're assuming that traction shouldn't really be taking place at this point. It could very well be if there is large sediment, but in theory, that's something that the upper course needs to break that sediment or move that sediment down into smaller pieces as it gets towards the lower course. Okay, so we can expect further downstream on the lower course solution suspension and saltation taking place. So I'll just highlight those key bits just before we finish. So solution in the upper course, traction should be in the upper course, saltation, the particles are finer in the lower course, but we won't necessarily see it. Suspension and solution should be in the lower course. So before we finish, just a quick summary of what we looked at. So for our 3 key takeaways, we're going to describe the different processes. So this is traction, which is the rolling of sediment, saltation, hopping of smaller sediment, suspension, floating of fine sediment, and solution, which is the invisible dissolved sediment. Then we need to explain how and why they change along a river. So higher energy has more power to move sediment. So in the lower course, we're going to find more transportation taking place, and also smaller sediment because it would have been eroded down or broken down to a smaller size by the lower course. Smaller sediment is more likely to be transported, and it's finer in the lower course. In the upper course, it's still large, hasn't been eroded down yet, so there'll be less transportation in the upper course. And then just linking these different parts of the river, the different processes that we expect. So in the upper course, there's larger sediment, which means traction could occur, but it can only happen in high energy events. And in the lower course, we're looking at saltation, suspension, and probably solution as well, but more evidently saltation and suspension, as the sediment is much, much smaller and the river has more energy to move larger quantities of it. Thank you for listening and have a lovely day.